Let's practice with a few more examples using the converse of the Pythagorean theorem. So again, we're trying to determine whether the given side lengths create a right triangle or not. Okay, so we're given the side lengths, and we're going to use the Pythagorean theorem to prove whether or not these three side lengths form a right triangle. So remember, the number that you're going to plug in for C is always going to be the longest side. In this case, it's going to be the 8. It doesn't matter if you plug in a 6 for A or a 6 for B, 7 for A, or 7 for B. The most important one to remember is that the A must be plugged in for C. So now let's give it a try. 6 squared plus 7 squared, we're trying to determine if that's equal to 8 squared. 6 squared is 36, 7 squared is 49, and 8 squared is 64. So now I need to add the 36 and the 49 together. And when I do that, I got a sum of 85. And 85 is not equal to 64. So when I used the Pythagorean theorem, I ended up with an equation that is not true, which means that this is not a right triangle. Using the converse of the Pythagorean theorem, we were able to determine that these three side lengths will not form a right triangle. We didn't have a picture to go with this one, but we were still able to figure it out using the side lengths. Let's try example 5. We're trying to determine if the given side lengths, 6 inches, 8 inches, and 10 inches, will create a right triangle or not. So the longest side is the 10. So if this is a right triangle, we don't know, but if it is, the 10 would be the hypotenuse. So I'm plugging in the 10 for C. I'm going to plug in the 6 for A, the 8 for B, and the 10 for C, since that would be the hypotenuse if this was a right triangle. I need to remember to put that question mark there because we're not sure if these are going to be equal or not. Okay, so let's go ahead and simplify. 6 to the second power, or 6 times 6 is 36. 8 to the second power is 64. And 10 squared, or 10 to the second power, is 100. So now I need to add the two numbers together on the left side. 36 plus 64 is 100. And then, of course, the 10 squared was also 100, which means they are equal. So by using the converse of the Pythagorean theorem, we were able to determine that, yes, this is a right triangle. This is a right triangle because the left side of the equation equals the right side of the equation. Let's do one more example together. Once again, we're going to determine whether the given side lengths will create a right triangle or not. We have 5 centimeters, 12 centimeters, and 13 centimeters. So the value that I'm going to substitute in for C would be the 13, because that is the longest side in these three. So I'm going to go ahead and put in the 5 for A, the 12 for B, and the 13 for C, as we just talked about. Now I need to simplify by squaring each of the numbers or raising them to the second power. 5 to the second power is 25. 12 to the second power, which is 12 times 12, is 144. And then 13 to the second power is 169. I need to add the 25 and the 144 together. When I add those two together, I get 169. And that is equal to 169. Yay. So that means that yes, these three side lengths will form a right triangle. I hope these 6 examples in this lesson have given you a stronger understanding of the converse of the Pythagorean theorem and how to determine whether a triangle is a right triangle or not.